Welcome, everybody. My name is Arup Nanda. I hope you can see my screen. It's important that the first screen should be showing right now. I hope you can see it. Just wait for it to resume slide. So, okay, perfect. So I can see that. As Francisco said, if you have your questions, if you could ask them on the chat window, so he will collect it and he will put it at the very end for me to go through it. A little bit about myself first. I've been an Oracle DBA. Actually, this is a little bit older slide. I have been an Oracle DBA for 19 years, and I'm still an Oracle DBA. That's what I do. I have been doing all that. I have not been a developer. I have not been anything else except an Oracle DBA. I speak at conferences. I have actually spoken at Latin American OTN tour about 2 years ago. There I visited Brazil, Peru, Colombia, and that's it, Brazil, Peru, and Colombia. And I had great fun in doing that. I write articles. You might have seen some articles in Oracle Technology Network. I have co-authored 4 books. I also provide some trainings and security audits. And yeah, I write most of my articles in my blog that's on there, arup.blogspot.com. I would encourage you to go and visit the blog to find out more information, especially for new things I keep on writing there. I try to put at least one blog every week. But of course, I'm sometimes behind, but I try to do that. So hope you can get something out of it. So this is a session. Why this particular session? Suppose, here's a question for every one of you. Most of you are probably Oracle DBAs. And this is a question generally asked to you, that if I have a 100 megabyte database and I have a 100 megabyte buffer cache, so that means I can put my entire database into buffer cache, correct? In fact, that's the question asked to you when they design systems, and particularly in Oracle Exadata, or if you do compression. This is a question I actually asked earlier when Exadata was introduced, Exadata X22. At that time, they said, well, your database is 50 terabytes. There's usually a 10 times compression factor using hybrid column compression. So that breaks it down to 5 terabytes. And Exadata has a fast memory of 5.3 terabytes. That's it. Your entire database can go into memory. Is that true? So if I have a 100 meg database, can I have a 100 meg buffer cache? I don't have to ever go to disk. That's, well, answer of course, since I'm asking you, you might know the answer already. It is not true. So then how much do I need? The answer might actually surprise you. It is actually 7 times the amount of database space you need in memory to have the entire database to memory. Why is that? Well, if you want to read up a little bit more on that, you can actually go, I can go through this presentation today. You can also read up a little bit more on that on my blog in exactly the same name. You can find out from there as well how actually Oracle takes up the buffer cache. But we're talking about Oracle RAC right now. You might know Cache Fusion is a mechanism to get the data from a different node. It doesn't have to go to the disk. What that means is if you have a 4-node RAC database, suppose, then all you need is 25 gig. I'm sorry, 25 meg memory in each of the boxes, and that should be about it. That should be enough to put your entire database into memory. But the answer is no, it doesn't do that. So the question is that if the Cache Fusion really works, how does an instance know where to get that buffer from? Because there are 3 other instances where to get the instance from, where the buffer from. And you might have seen that a few times also, something called buffer locks or block locks. How are they different from row locks? You might have seen that before. In fact, some people who get confused with block locks in Sybase or SQL Server, which is basically a lock on all the rows of that specific block. In Oracle, there is a concept of buffer lock or a block lock, but that is nothing at all to do with the row locking, and you'll see exactly why. And you might be also confused about things like global cache service, GCS, global resource directory called GID, or global NQ services called GES, etc. So these are not just acronyms. What exactly do things actually mean, and what function, what role they play in the Oracle RAC architecture? Today, we will go through all that, and I will see exactly how it works. And I will show you all this using a demonstration as well, because without the demonstration, nothing really becomes a simple stick. My problem is that I just had to reboot my system about 5 minutes ago, so my database is still coming up. I hope it will be completely up by the time I start my demo, but if not, you have to bear with me a little bit. Okay, so here's the thing about buffer cache. As you might know, Oracle database has sites on a physical disk, and when you say select star from EMP, Oracle creates something called a server process, and that server process gets the data from the database. But the server process doesn't go and select the columns from the EMP table directly. You might know that already. The least identifiable unit in an Oracle database is a data block. So what Oracle does it gets the data block from the database files, move the entire block into something called system global area, or the buffer cache in the system global area. Buffer cache contains placeholders for these blocks to go in and stay there. So when you say select star from EMP, what Oracle does is that it selects the block from the database itself and then moves the block over to the buffer cache and puts the buffer there. And from there, it extracts the rows and then gives to the user that he wants. That's how the Oracle buffer cache actually works. In a RAC database, however, there are two buffer caches because there are at least two, maybe more than that. So you have two buffer caches in each machine, so you have that system. So at this point, somebody says the same thing, select star from EMP on a different instance, not the instance you selected before. So in that case, there are two choices. One, the server process can go to the database again, get and put in the buffer cache and give it, or it can go to the other instance and get it from there and put it into this instance and give it to the user. This process is called cache fusion. And by doing so, this instance number 2, bypasses the going to the disk. And as you might know, disk access is way, way slower compared to memory access. So this makes sense in that way. It is pretty quick and it gets it up, cache fusion. All right, that's good enough. So here's the question. So does it mean that every time an instance requests a block, it will go and get the buffer from a different instance? Is that the case? Well, the answer might not be obvious. No, of course not, because the block in the other instance might not be recent enough, might have been changed, so on and so forth. So that's the first question. Second, this is just two instances. What if there are three instances? So in a buffer, when an instance requests a buffer, it could be found in instance number 1 or instance number 2. Which one should it go to and get it? So there are a few options there also. One, so not only you have an option, first, should I go to the disk or should I go to the other instances? If I go to other instances, which instance should I go to? And there are so many things in that case. So you got to understand this. Oracle has to make a decision somehow to go and get this. How does it decide which particular option to take? Well, that's what is the very most confusing thing about cache fusion. If you understand that, you'll also understand how to tune the RAC database properly. So that is all about. Let's see actually how that works. So before you know that, you have to understand one more thing, something called buffer state. A buffer, which by the way is a block that you retrieved from the database itself and has put into the buffer cache. That's a buffer. So buffer and block are basically synonymous. The only difference is that a block is in the database, and the same block, when it goes to the buffer cache, is called a buffer. So it's in memory. That's it. The buffer can be retrieved from the database using two modes. One, It's called a consistent read. Another one is called correct. Well, how does Oracle decide which state to get it in? Well, this is the reason why. There can be, if your intention is to modify that buffer, in that case is retrieved in the current mode. If the intention is not to modify, simply select from it, in that case, it is retrieved using consistent read mode, CR mode. Let me repeat. If Oracle gets that block from the disk to the buffer cache for the intention of modifying something in the row, like update or delete or insert or something, then it is retrieved in correct mode. If the intention is simply to select from it, then it is retrieved in the consistent read mode. There can be several CR copies of a buffer, and you will see why there are several copies of the buffer. But there can be only one current mode for an instance. And why is that? Again, you will see that why is that the case. Each current buffer is called shared current. When it's a shared current, that means if you find a buffer in a shared current mode, that means if you find another buffer in a current mode, any other instance, it will also be in shared current, and that content will be identical to this instance. But what if something gets changed in one of the buffers? In that case, that buffer is called exclusive current. So there can be only one exclusive current in the entire instance, in the cluster. But there could be multiple shared currents in the entire cluster, one shared current for instance. But in that case, all the shared currents in that cluster will be identical to each other. But if that is not guaranteed, then that's called CR mode, current read mode. So what is current read again? Current read is something, is a snapshot of a buffer at a particular time only, not anything else. And if that particular time, another block is, another row is retrieved, Oracle creates a copy of it, and so on and so forth. So there could be multiple CR copies. But there cannot be multiple current copies because there can be only one current, and we'll see why that is the case. Let's see the first one. Here is what happens. Let's say I have two instances in this RAC cluster, two nodes. Instance 1, instance 2, going to one database. So as I just told you earlier, the least identifiable unit in a database is a block, and that block happens to be there. And that block belongs to a table. So if you blow up that block, it looks like this, suppose. That's called row 1. Let's say there are 4 rows in this block, and row 1, row 2, row 3, and row 4. Let's say somebody says, in connected to instance number 1, sorry, it's a little slow. Don't know why it is slow, but just, yep. Somebody says, update row number 1. What happens then? First, Oracle has to do, first thing, get that block into the buffer cache. So it goes into the buffer cache. Okay, it goes into the instance number 1. But I'm updating row number 1. Therefore, what Oracle does it updates row number 1. As you can see here, it did not update that in the database yet. Why not? Because when the update, insert, delete happens, Oracle does not do immediately update in the database. Eventually, database writer, the DWR process, that's the one that moves the dirty blocks from the instance back into the database. Right now, it's only in the buffer cache of the database, of the instance 1, that is row 1. Then somebody says update row number 2. Remember, update row 2, not the same row, a different row. But where is row 2? Row 2 happens to be in the same block as row 1 in. And because of cache fusion, instance 2 is not going to get that from the database directly. It can get that from the memory of the instance 1. So it makes a copy of it back here. When you make a copy of it, see that row 1 is also changed in that copy because it's a copy. Row 1 is not the previous version, it's the same copy here. But I'm updating row number 2, so Oracle updates row number 2. I put a red and a green color to signify which instance does the modification. Red is instance 1, green is instance 2. You can see now there are 3 copies of the block. Here, because there are 3 copies of the block, Oracle has to somehow identify that which copies are what. So as you might know, in Oracle, the clock is called system change number, SCN. Suppose when this whole thing started, the SCN number was 10. When I did update row 1, it became SCN number 20 in instance 1, and when I do update row number 2, it became SCN number 30 in instance 2. See here, I have now 3 copies of the same block in 3 different places. One in the disk itself, one on instance 1, one on instance 2. As you can see, these 3 copies are completely different from each other. The one on the disk, SCN number 10, has no update at all. SCN number 20 on instance 1, row 1 is modified there. Instance number 2, SCN number 30, row 1 and row 2 both are modified. So these are different versions of the cursor, SC, that is, they are identified by SCN number. Now here is another little thing to consider here. Okay, it is slightly slow for some reason. Let me just wait for it to come up. Oh, come on, slow. Okay, good. Now, let's say someone says update row 3, remember, not row 2 or 3, or row 3 on instance number 1. Now, what should happen? Should Oracle go and update the row 3 in the buffer it has? It could do that, but here's the problem. What's the problem? The problem is, at that time, it doesn't know which block is the most current one. Because if you update row number 3, on the buff copy you have on instance number 1, there, row number 2 is not updated. Row number 2 has been updated on instance 2. Similarly, if you update row number 3, how do you know that row number 3 also has been updated on the copy of the buffer on instance 2? It doesn't. So Oracle cannot have these multiple copies of the buffer where it cannot know exactly which one is the most recent copy of the buffer. It has to hit the most recent copy of the buffer and make the modification there. That's the only way to guarantee that all the changes are propagated. Imagine this way. If you are a group of DBAs and in a single, doing a same database update, suppose. Now, say you need that ORA file, you want to update that. And all of the DBAs in the group are going after the same init.ora. So let's say you make a modification. At the same time, somebody else makes a modification to a different parameter in the init.ora file. What's going to happen? How can you guarantee that one person's changes, every person's changes in that file will be protected? There is no way to know that. So what do? So we say, let me finish my updates, and I'm not done yet, but I'm going to give the entire file to you, what I've done the updates with, to you. You can make your updates. Once you're complete or you are halfway through or something, give that file back to me. I'll make my modification. I'll give that file back to you and back and forth. Or let's say you are writing a document, a Microsoft Word. If you write you with your colleague, 2 of you are trying to collaborate on a topic. If you start writing and at the same time the other person starts writing in a document in his computer, how do you know what are the changes done by you and by him, and then how do you merge it together? You can't. The best thing to do is that write up everything, even if not complete, give it to the other person. Let the other person complete everything and give that copy back to you so you can make your changes. That's the only way to guarantee that. That's exactly what Oracle does as well. When you say update row number 3, the first thing Oracle does is that, okay, find out which one is the most recent copy of the buffer. Oh, by the way, that happens to be SCN number 30, and that happens to be on instance number 2. So instance number 1 says, hey, instance number 2, give me that copy with SCN number 30. And that copy goes over here, and Oracle makes a modification to row number 3. Now you can see that is called SCN number 40. Now I have 4 copies of the same buffer. You can see that now, row 1, row 2. Oracle does not overwrite the copy it already has. It gets a copy from the other instance and makes a modification there. This is the reason why you need multiple copies of the same buffer in the buffer cache. So see here, let's say I have 8 kilobyte block size, which is not normally the case. Now, if I have 8 kilobyte buffer cache, I won't be able to fit all the rows here, buffers here, because I just consumed 2 buffers for the same block. So if I have exactly 1 block, 1 megabyte of database size, I need 2 megabytes to fit this into memory, and so on. So actually, you'll see much more than that. But you see that's the point here. Point is that you're expecting that buffer from a different, you're copying the buffer from a different instance and then making the modification here and then doing that. Okay, this is another question. So SCN number 1, it goes into instance number 1, other time because it's number 20, and then it goes to this one. Question is, how does Oracle know which one is the most recent copy of the buffer? It has to maintain some kind of a register, right? Block address is so-and-so, or block ID is so-and-so, and here is the SCN number. Can you imagine what's going to happen? That list or that table becomes the point of contention. Everybody has to go to table to find out what the most recent copy, and they will wait up until somebody else in front of them is complete, and so on and so forth. Similarly, an instance, when they next update to the block, they also have to wait until somebody else is in front of them is out of the picture so they can return the lock, and so on and so forth. So it becomes a single point of contention. Instead of doing that, Oracle makes a very simple thing. What it does, it simply flags or labels a block as called exclusive current. So exclusive current means this is the most current copy of the block. That's it. If I have to go and find out in the cluster, give me the most recent copy of the buffer, I don't have to go and check a table or a list somewhere. All I have to check is the buffer. Hey, are you exclusive current? No, I'm not. Move on to the next one, so on and so forth, until I find the exclusive current. So when this thing happens, when update row number 1, the first instance that gets it, and that, of course, is exclusive current. What that means is no other instance will have a buffer more recent than this particular copy of the buffer. Okay. Now, when update 2 happens, instance row 2, instance number 2, remember that copy moves from here, from instance 1 to instance 2, and becomes SCN number 30. Then we can't call that exclusive current anymore. So we call that consistent read copy. Why not? Why can't we call it exclusive current? Well, it's not the most current now. Look at this information here. In this case, the most recent copy of the buffer is instance 2, because that's where row number 2 has been modified. Row number 1 is not modified. Row number 2 is not the only one modified in the most recent copy of it. That's why the instance 1 copy becomes consistent read, and the instance 2 copy becomes exclusive current. Let me repeat that. Instance number 1's copy was exclusive current because that was the first thing that it brought from the database, and that was the only one updated anywhere in the cluster. When instance 2 updates the same buffer, it creates a copy from instance 1, but the copy in instance 1 is no longer exclusive current. It becomes consistent read, that is because it's not the most recent one, and instance number 2's copies becomes exclusive current. Similarly, when update row 3 happens, which is on instance 1, remember Oracle makes a copy from instance 2 back into instance 1, then that copy has to become exclusive current, because that's the most recent one. And the copy on the instance 2 side becomes consistent read. See that, how that thing called the consistent read? So you understood 3 important concepts. Concept number 1 is that SCN number is attached to the version of the block, and the block is either called consistent read copy or exclusive current copy, or sometimes called shared current copy. You'll see what that means actually afterwards. So putting it all together. When the block comes from the disk to the buffer cache, if the intention is to modify it, it's in current mode. If the intention is to select from it, it's in CR mode. There can be only one shared current and multiple shared currents in the cluster, because it can be one shared current in instance 1, one shared current in instance 2. But if that is the case, then both the shared currents will be identical to each other. If it is not identical, then there cannot be shared currents. In that case, one of them will become exclusive current, and everybody else will become CR copies of the buffer. And that's what we think about. Okay, let's see what we see. I think at this point we see a demo. I was going to bring my database up. Oops, hope my database is up now. Just bear with me. Let me see. Okay, good. So let me see if my database is up. Oh, Oracle is not available. Okay. Let me see if my instance 2 is up. Instance 2 startup is initiated. Okay. I don't know that why it's stuck. Okay, I'll correct it. Alter database. Let's see what happens here. I'm starting up. So here, let me see if my database is up here or not. So I have two instances in this to demonstrate. With node 1 and node 2. I call the database name PDB, and the database instances are called PDB1 and PDB2. And so for simplicity, I'm showing node 1 in white and node 2 in yellow, so you can see the difference here. Let me see if my database is up here. I see the plus, and hopefully the database comes up. This is the problem with demos. You never know when it's going to end. Well, you never know when it's going to have a problem. Okay, my instance 2 is up. Let me make sure that I have every other instance. Well, of course I don't. GC dollar. Oh, sorry. Okay, only one row is up. Oh, I say one instance is up right now. And there's some problem in the first instance. Hopefully it will come up in time for me to continue the demo. If not, then I have to continue the presentation. I apologize for that. It always happens. Go Oracle. Come on, come on, come on. Okay. DBTF. Let me see what exactly is going on there. Okay, instance finally started. At least the instance started. Let me see. Hopefully it is. Database mounted. Good. Finally. So it should show two instances now. Come on, move it quickly. Okay, it's moving. Move it. Okay, so while this is going on, let me just go through my presentation name. Hopefully it will come up by the time it's there. So before I do that, so one more thing. So you understand the concept of CR mode and current mode. Now, let me go back to my screen a little bit here. Now, why is that important, this consistent read and exclusive current? Of course, the number one thing is to find out what is the most recent copy of the buffer. That's the number one thing. What else? Well, look at this thing here. The database block, it is still at SCN number 10. So we modified 3 rows in the block, but none of the changes have been reflected so far in SCN number 10. Well, you might be wondering, well, in that case, how does Oracle protect the data? Suppose all the changes we have done so far, row 1, row 2, row 3, they're all committed. If the instance comes down, all the instances come down right now, the database will still show 10. Wouldn't that be a problem? Shouldn't that should be an error because we have done these commits already in the database? Well, it is something. When you make a change and you commit the change, that information goes into something called redo log files. When an instance comes back up, at that time, Oracle reads to the read log files, finds out the changes are required, what changes have been committed and not been written to the database files yet, and then start writing to the database file to make it consistent. That operation is called roll forward. Data files are written in asynchronous manner. There is nothing at all to do with the commit or the changes. They are written by a process called DB writer. At the time it is most convenient, like all the DB writer, all the data buffers are filled up, or somebody needs some space and doesn't find it. That's the only time the data block DB writer writes to the data file. That doesn't otherwise. So in case of a failure, Oracle reads the redo log files and apply the changes. Now, suppose in this picture, you can see that instance 2 fails. What is the problem? Well, what Oracle does is, instance 1's recovery processes read through the redo log file of instance 2 and find out which changes are supposed to be applied to the database at that time. Well, it will find out it's not that difficult. It is because the most recent copy of the buffer was not in instance 2. It's in instance 1 right now, the most exclusive current copy of it. Oracle can go and write that to the disk very, very easily, no problems. There's no need for a recovery from the read log files. But suppose opposite happens. Let's say instance 1 crashes. Instance 2 has not crashed. That means the recovery processes of instance 2 will now go through the redo log files of instance 1 and try to find out which one to apply. And when they do that, they will find out instance 1 has modified up to SCN number 40, whereas the database is still at SCN number 10. That means it has to go read through all the changes between 10 and 40 and apply that to the database. And it will do that eventually, by reading all that log entries. It will do and look it up. But did it have to do all that? Look at instance 2's buffer cache itself. That's at SCN number 30. It didn't have to go through everything from 10 to 40. It could simply start with 30 and apply the changes from 30 to 40 to make it the same. As you might know, reading through read log entries and applying the changes is a very expensive process. So Oracle could have avoided by taking the copy from instance 2, which is still available up and running, which is SCN number 30, and applying the changes only 10 SCN numbers. Instead, it goes through 10 to 40. Why is that? That's because instance 2's buffer cache shows consistent read. Remember what consistent read is for? It is supposed to be for buffers that were retrieved from the disk for the intention of selecting from it, not for the intention of modifying it. That's a huge problem. If the intention was to select from it only, Oracle knows, or at least thinks, that this buffer copy itself is not good enough for recovery, because it was made for consistent read only. Why it is good for recovery? The intention was to select from it. So I can't use it to do my recovery. But in this case, it actually could have. Why? Because this thing was not consistent read to begin with. This copy was actually exclusive current before. Remember that? Earlier it was exclusive current right here. And later on, it became consistent read. So just because it becomes consistent read doesn't necessarily mean it's a bad thing. It's not good enough for recovery. It is good enough for recovery to make it faster. But it cannot because it's called consistent read. That's why Oracle assigns a special status to this buffer called past image. So by using past image is exactly the same as consistent read. That means it's not current anymore. Somebody has modified some other instances, and therefore this particular one is now no longer current. But in case of a problem in the other instance or a recovery is required, this past image copy, or called PI copy, can be used for recovery purposes only. If the recovery is not required, past image is also not required. That becomes CR copy. All right. So let's just see that in action. Hopefully my instance has come up by now. Yep, my instance has come up by now. Let me make sure that I have both the instances up and running. So so not V dollar, V dollar. Okay, this is it. So what I'm going to do is that I have, as you can show here, I have the white one for node 1 and the yellow one for node 2. That first. Let me show you a simple script. Let me connect as here. Set echo on so you can see exactly what I'm doing. Set echo on. And by the way, if you want to reproduce them on your own system, you can do that. I'll be posting all the scripts I'm using today on my blog. So you can download and be free to experiment on this one. CF setup. I am creating a table called CF demo. I'm dropping the table and creating the table with just 2 columns, column 1, column 2. And I'm inserting 6 rows into the columns. When I'm inserting 6 rows into columns, it will show you that I'm just simply putting some values here. Now, question is, how do I find out which particular block in this table occupies and how many blocks it occupies? I can do that by using something called DBA extends. And I can see here, this particular table started with block ID 86248 and it occupied 8 blocks. Does it mean that all the 8 blocks in this starting with block ID 86248, 86249, 50, 51, 52, 53, etc., all of them will be occupied? No, because some will be header blocks, some will be for bitmaps. Only few blocks will be occupied, not necessarily all the blocks. So how do I find out which blocks are occupied? To do that, I can use this. This is the syntax I can use. DBMS row ID relative file number, and relative block number. I'm sorry, row ID block number. So I can see here, row number 1, 2, 3 happen to be block number 249 here, and 4, 5, 6 happen to be 250, 250, 250. So I just have 2 data blocks occupied. That's it out of all 8. And one of them has row ID 1, 2, 3. Other one has the values 4, 5, and 6. So we got that. Okay. How do I find out which blocks are in memory or buffer cache right now? To do that, I have a very simple view called $VH. That's a $V view, VH here. You can see that here, file number, block number, status, etc., etc. OBJD, that's the object identifier and everything. But here's a misnomer though. That's not an object ID. That's called data object ID, which is also there in DBA objects. So this is actually a data object ID, OBJD. From here, I can find out which buffers of this particular table are in the buffer cache right now, because they keep on going and coming out. So I can guarantee that they will be definitely there. Status column is something that shows you what status these things are in right now. Class number tells you what kind of block it is. Is it a data block, index block? Is it a bitmap header block? Is a segment header block? And so undo segment block, etc., and etc. Or a temporary table set block, all that. And this is what gives you the idea behind that. So instead of you trying to figure out what exactly the block are supposed to be, so I wrote a very small script to show you what the different things are for here. So first, we find out the data object ID. This is how you find out the data object ID from DBA objects. In this case, it happens to be the same data object ID. You can see that DBA object ID 77184. This is because it will become different if you ever move this to a different table space or the same table space, rebuild it, and so on and so forth. The data object ID will keep on changing. So that's the one. In this case, because I just created this one, there's nothing like that for 77184, but there's no guarantee that will be the same one. So you should be checking first the data object ID, and that's the one we'll be using right here, 77184. Okay. Then I will look at this thing called VH. This is how I have done VH from VH, where object is equal to the data object ID. I will provide that. And the class number is something I already put a decode statement for you to show you that how this actually decode works. There you go. Okay, so we got 3 blocks of this particular table in the buffer cache of instance number 1. And what is the status? Exclusive current, exclusive current, exclusive current. Why? Well, because we just created this object in instance 1. Therefore, instance 1 has to create all these things in the memory, in the buffer cache, and then create those things in the table. So that means the most recent copy of the buffer happens to be right here. Let's go to instance 2 and let's do the same thing. Do you have any of the buffers of this table in that instance? Let's see. DBH, object ID same, no rows. How come? Well, because we didn't select or do anything with instance 2 yet on the table. Therefore, instance 2 doesn't have a buffer cache. So this is a very important point of a RAC. Buffer cache, there are 2 buffer caches, but that does not mean they're identical to each other. They only make sense when you're selecting from them and not from anything else. Just want to make sure that I'm not running out of time. I'm not running, I have plenty of time. Okay, fine. So we got that. Now, let me do one thing. Now, let me select. Okay, let me set echo on. Sorry, set echo on. Let me select something from here. Select one first column. Okay, so I'm selecting from this table where column 1 equal to 1. Remember, I have 3 rows in the first block, so I got something from here. Once it's selected that, let me find out if I have something in this object ID. By the way, what is object ID again? 77184. I got that. Now see, now I got all the data blocks in my buffer cache here. But hold on a second. I simply selected only one row. So, and that one row happened to be on block number, what is it, 86249. So why am I getting 86249 and 50? I didn't select anything from 86250 block number. Everything I got was only from 86249. So why did Oracle get that as well? Well, if you remember, I don't have an index on this specific block or on the table. So when I say select star from this table where column 1 equal to 1, Oracle doesn't know which particular block will satisfy the condition. You just do a full table scan, that means get all the blocks, and then select that what I'm looking for. That's the reason why I got all the all the blocks of the table into the buffer cache. But here's some important things you can see that here. Here, I got 86249. I got 2 copies. One copy with SCOR, that stands for shared current, and one copy with CR, that stands for consistent rate of course. Why are there 2 copies? Well, remember, because of cache fusion, Oracle gets it from the other instance. Remember that? When it gets from the other instance, it always gets it with a CR mode. Then it modifies that to become SCR. But it doesn't modify the buffer it just got. It creates a copy of that buffer and then makes that copy a SCR or shared current. But why doesn't it delete the first one it got to begin with, which is CR copy, this particular copy? Well, why delete it? Because somebody could select from it at that point in time. It's possible. So why select it? So why delete it? That's why Oracle leaves it like that. So now it has 2 copies of the same block, 49. One copy is CR, other copy is SCR. Now let's go back and find out. Remember the one thing I told you? If it is, oh, come on. If it is a SCR, shared current, what does that mean? That means this is a shared current across all the instances, right? There cannot be exclusive current. In this particular case, 86249 was exclusive current, SCR. So what is the status right now? Will it still continue to be exclusive current? If there is a shared current over here? No. By definition, you can't have an exclusive current in one place and a shared current in other places. Why not? Because exclusive current means exclusive current. by definition, everybody else are not current anymore. It is exclusively current. And everybody else has to become something else. So when this became shared current, this could not have remained exclusive current. Let me see what else has become then. VH 77184. It's a little slow. Come on, come on, come on. See that? Now it is a scar right here. Now it's a scar here as well. The question is that what does a scar mean? A scar means shared current. That means Oracle can say I can go to instance 1 here or instance 2 here. It doesn't matter. I'll get the exactly same data because they're both most recent and they're both identical. That's why they're called shared current. Now, you got one here, shared current here, you got a shared current over here. Here you got a CR copy because there was a copy instance number 2 got for the first time from instance number 1. Now, let's do another experiment. Let me do an update here. Update. Let me update row number 2. It's a different row. When I do update row number 2, let me see what happens. VVH and sorry, what is it called? 771. What block number is that? 77184. 77184. See that here? Now it has become exclusive current naturally. And here, what do you see here then? If that is exclusive current, this thing cannot stay shared current anymore. Let's see what it is now. 77184. What is it now? That is now CR. You can see that here. So now you have a CR here and exclusive current over here. Block number 2. Now, that's interesting thing. Let's see what happens here. If I update a different row here, row number 3, suppose, which by the way is also in that block number 249. Let's see that. VVH 7718. What row is that again? Block number 77184. 84. And look at that now. 249 is exclusive current because now I modified it over here. And if I go to instance number 1, 77184, look at that. That has become PI, past image. Because that was exclusive current, remember? Now it is past image. So you can see that how the exclusive current goes back and forth between the two instances to signify which one is the most recent copy of it. So a few things. You can see here, 249. Look at 249. 1, 2, 3, 4, 5. It has 5 copies of the data block. 4 are CR copies and 1 is exclusive current copy. Here it has 1, 2, 3, 4. 4 copies. 3 are CR copies, 1 is a PI copy. You can see that one particular block has so many copies. In fact, you could go up to 6 CR copies, which by the way is changeable, but by default is 6 CR copies, and 1 PI copy, and 1 is an exclusive current copy or a shared current copy. So you could go up to 7 copies of the same block in the buffer cache. So going back to my first question, if you had a 100 megabyte database, how much buffer cache do you need to put the entire database into memory? The answer is 7 times 100, so 700 megabytes. So if you have a 100 gigabyte database, you need 700 gigabyte of memory to fit the entire database into memory. Go back here. Now let's go back to this discussion over here, the PI. You know, the PI copy has only one purpose, to enable in recovery process. That's it. PI copy doesn't say is the most recent copy. That's not the whole point at all. So recovery. So at what point is recovery not required? Well, when the checkpoint starts, the data files are updated immediately. There is no recovery required at all. So in that case, let's see what happens when you do a checkpoint. By the way, checkpoint also happens automatically from time to time, but I'm just forcing it right now. Alter system, checkpoint. Why this is coming up? Just find whatever. Checkpoint. Okay, good. Now let me do VBH one more time, 77182 or 84. What is that again? 82 or 84, 84, sorry, 877184. Look at that now. Now that TI copy is gone. Now instead, it has become CR. So now you see the point here, CR copy and exclusive current, how it goes back and forth. So this is how Oracle puts an exclusive current. Next question you might ask is that, then how does Oracle mark something as exclusive current? Like for example, we saw the exclusive current became back and forth between instance 1 and instance 2. Then what that means is, when Oracle moves it, that something was exclusive current before, now it is no longer exclusive current, now it's CR, or vice versa. How does Oracle know that there can be only one copy of the exclusive current in the entire cluster? We're talking about multiple machines here, not a single machine. To do that, Oracle uses a very simple thing called a lock. So you need an exclusive current lock to make it exclusive current. If you don't find the lock, you cannot make it exclusive current. Very simple as that. That's why you see something called lock element. That's how Oracle uses it. So this lock is something on the buffer level just to mark what is the status of that block. Is it exclusive current or it is no longer exclusive current? You can see here, when it becomes CR, there is no locking at all. This lock element becomes 0 because no lock element is not required. Whereas if it's current, lock element is required. So that's the difference between exclusive current and CR current and the locking. So let's go back to our variable 3 over here. So if I go see the time CAS fusion in operation, time T0, let's have 3 sessions connected to 3 different instances. So first, I select staff from T1. The data file, sorry, the block comes from database into instance 1. That is a shared current because nobody has modified that yet. And this is in this place, that's what's called shared current. Then session 2 says select staff from T1. Then that block comes from instance 1 to instance 2 by CAS fusion. That copy is CR copy. Then somebody says T1, update T1 and session 3, which is connected to instance number 3. At that time, that again comes from instance 2 to instance 3 and by CAS fusion, and that copy becomes exclusive current copy, and the other 2 become CR copies. Then somebody says update T1, and this comes from instance 3 to instance 1. That becomes exclusive current copy, and the other copy becomes TI copy, as you can see that before. And when you do all the system checkpoint, the PI copy is gone and is converted into a CR copy. So this is how Oracle does this information back and forth. And Oracle uses a locking mechanism to identify which block can or cannot be exclusive current. That is called a buffer lock. So this is very different from row lock. Buffer lock is simply put by an instance to see which block can be an exclusive current block. So what happens is that if you have, so instance number 2 wants to have to get an exclusive current on this block, first it has to go and get the exclusive current lock, and only then it can become exclusive current copy. If it doesn't get the lock, it cannot make it exclusive current. That's the whole idea behind a buffer lock. So that comes to the next one, global CAS services. Here's a service that provides a buffer from one instance to the other instance, but it doesn't know who has what kind of buffer lock. So next question is that who then knows that? Or that service or the mechanism to know who has what kind of lock is called global NQ service. NQ, as you might know, is a synonym of lock. It used to be called Dynamic Lock Manager, DLM. That has the information on the locks and the buffers. So again, that's that. And if you want to see what locks you have, what buffers, you can see that from a view called v$lock element or x$le if you have access to the system. So each buffer in this case has, in a RAC instance, has 2 queues. One is a grant queue, that means where the requesters are queuing up to get the lock. Similarly, something called convert queue, once the locks are granted and they move into convert queue, the requesters now pick it up and then return it and then do what they want to do. Now somebody has to make sure that this thing is going back and forth. Well, it cannot be somebody. It just queues one above the request queue and the grant queue. It has to be in a memory somewhere. It cannot be a table. Why is that? Because if it is not in the memory somewhere, if it is in the If it is in the memory somewhere, what happens is if it is in a file somewhere, it cannot be, it has to be copied over and replicated across all the instances, which is going to be very time consuming and becomes a single point of instance. Therefore, Oracle doesn't replicate them. It simply gets it from only one instance at a time. So one buffer information is stored in only one instance. It is not replicated. If anybody else wants to get the lock, it has to go to that instance and request the lock on that buffer. That instance is called a master instance of the buffer. Let me repeat that. That instance for a specific buffer is called a master instance of the buffer. In RAC, there is nothing called a master instance of a cluster. Each buffer has a master instance. So let's say I have a 2-node RAC cluster. I have 200 blocks. It is possible 100 blocks will be mastered by instance 1, the rest will be mastered by instance 2. That's it. So say block number 1, instance 1 is a master. So anybody wants lock on block number 1 has to go to instance 1. Block number 2 could be mastered by instance 2. So anybody wants block number 2 locking will go to instance 2 and so on and so forth. And but next question is that how do you know what instance is the master of which block? Well, it's like a telephone book or a phone yellow pages. So that information is stored in a memory structure called Global Resource Directory, GRD. Now that information is replicated across all the instances. So without that, the instance cannot know. So who is requesting cannot know where to go. So that is kept in all the places. And if you want to find out which is master of what, you can use this query. But one caution that this query is very resource intensive. So don't run in your production system as a basic area. So in summary, buffers are gotten in 2 modes. Correct mode, which is something needs to be modified. CR mode is something is selected only for reading. Every time one node wants a buffer, it gets a buffer, copies a buffer first, then copies to a different location, and then modifies to whatever, like SCOR or exclusive current or something. There can be only one current state of the buffer in the instance in the shared mode, and only one exclusive current in the entire cluster. That's it. Each buffer has a master node that holds the information who has the lock and who is requesting that lock. That's it. And that information is put into something called a Global Resource Directory, or GRD. With that, I hope you got something out of it. Interesting. Thank you very much. You can download the script. I just showed you here from my blog as well after some time. And I'll now I'll welcome. I know I'm over time, but I will. If you have any questions, I'll be more than happy to answer them right now. Francisco, I'll wait for your question.
Hi, Arup. Can you hear me?
Yes. Yes, I can. Thank you.
Hi. Thank you so much, Arup, for your time and to be give this big honor to have you presenting through webinar to all Latin America and also to New Zealand people and some people also in Spain and in New York, in US. If you, I would really appreciate it, this opportunity, and the next webinar you're going to will be giving to us next month. And that's a huge honor, and thank you so much for that. I was asking the audience if they have any kind of questions. I got no questions. Looks like they are happy with everything you gave it. I will just repeat that in Spanish to see if anyone have any kind of question. Gracias a todos por la participación. Yo le estuve mandando por chat unas preguntas preguntando si alguien tiene algo que quiera preguntar a Arup Nanda. Si alguien tiene, por favor, que lo escribe por el chat o que levante la mano, apriete el botón de levantar la mano, raise your hand, para que yo le pueda abrir el audio, caso quiera hacer una pregunta directamente a Arup. Let's see if anyone have any kind of question, Arup.
Okay.
All right. Looks like no one raised their hands. No, okay, we have one question. Oh, no. Basically, they are saying that no, thank you so much. This was being a fantastic presentation and was very descriptive. They don't have no questions. Now I got a second one and try to open. Just 1 second. Now they're basically saying that they are happy with everything. Arup, thank you so much. And the next opportunity with Arup will be next month. And if you want to say something to close, Arup?
Yeah, no, but thank you very much for the opportunity and honor to be presenting in front of you. I wish I could do more of this. I hope you got something out of it. And again, I invite you to visit my blog. I'll have information there as well. And the scripts I gave you, I put here, I will put in the blog right away. So please go and download that from there. And Francisco, will you be posting this in your website, or they can go to my website and get it directly?
Yes, we can post to the website because the recording of the webinar will be posted at OracleMania, the our online community for LAOUC. And
okay,
if you want, we can post the PPT or something, or the scripts. We can also add right there. We can also make the link to download that from your website if you want it.
Okay. Sounds good. I will certainly. Well, my website is in my blog, which is arup.blogspot.com, and that's it. I'll put it there, and of course, you're welcome to put the recording there. So I'm sure they can get things from both sides.
Thank you so much. And Arup, I will take your word. If you say you want to give more webinars, I will take it.
Okay. Well, I have one coming up in July, so
yes,
go from there. I think I hope everybody joins in July. Thank you.
No, thank you so much. Have a nice weekend and have a great evening in New York.
You too. Thank you. Bye.
Bye bye. Bueno, muchas gracias a todos y aquí concluimos el webinario y lo esperamos ver para el próximo webinario de Arup en julio. Yo le voy a estar mandando a todos la información del próximo webinario, a los que se registraron y participaron de este webinar, y también en la página de OracleMania, en el front page, ustedes pueden ver todos los webinarios que van a estar surgiendo. Para este año tenemos aproximadamente 45 webinarios que se van a estar realizando. Un 40% en inglés, y un 40% en español y un 20% en portugués. Bien, muchas gracias a todos y nos vemos en la próxima. Que tengan un buen día.